yeah, we are skipping 3.7 for now, so don't throw it away. I don't know, we'll probably go back to it, but you already covered it on your test. So, couple reminders, homework, well, make sure you check the board. I know it's hard to fix in front of it, but just as like, you know, when you come in or when you leave, maybe take a look. The dates usually are, I don't know, but the learning targets, like what you should be filling out on the pink sheet by the time we're done with this, those are the targets. Homework assignments, any grades that are coming up, assessments, and homework checks. So don't forget, yesterday we started that sine cosine quiz. If you weren't here yesterday, Michael, I will explain that to you, so remind me. It's in a different place. Okay, Michael? In a different place, so I'll explain that to you. And the progress monitoring, which is on college board, both of those things are due next Tuesday. So progress monitoring is 10 homework points, as you know, and the sine and cosine quiz is a regular quiz. And a lot of you got really good grades on it, so that's beneficial. Yeah.
So if you flip back, it'll be able to show the thing.
Yeah, I know. That's fine. I mean, if you're watching this, you're one of my students, you know what I mean by the board, right? Like, and then it's upside down. Huh. Yeah, there's a way to fix that, but. Okay. Also, is there anybody else that needs a calculator? Is wanting to get a calculator and hasn't done the thingies yet? Anybody else? Okay. So, have you guys done the QR codes yet? Okay. Once you do, make sure you sign the paper over there and then tell me that you signed it. Okay. And then I can check that you did the QR code, and then I'll give you the go-ahead to go see Ms. Amio Pizzo to get it. Uh-huh. Yeah, I do. The square root curve. By the way, it's a really commonly used curve. So if you're ever like, you know, I don't mind sharing it with you, but if you Googled square root curve, it pops right up. So it's not like something I made up. But yeah, I have it. Yeah. Yeah. Yeah, this is just, do you want one to have for your own use at home, you know, whatever, then you'll also bring it to the AP test if I give you one. But if you don't take one, I will provide one for you on the day of the test. The whole point of this is I now have one for every single one of my students, that we have them available. So if you want it, you can have it. I can't find it at the moment, but I don't want to take up too much time. Remind me, because it's here somewhere. I'm just trying to talk and do this at some time. But you can also Google it. It's easy to find. Okay. Calculators. Okay, we talked about that. I think that's everything. All right. So we are starting today with 3.8, and we're going to go all the way to 3.12 for our next test. Okay. So 3.8 to 3.12 is our final test, second of 2 tests of the quarter, and it'll end up the last couple days before spring break, which is in 2 weeks. So our test is going to be 2 weeks from today and tomorrow. So Wednesday to Thursday. March 6th, March 7th, and then March 8th is the Friday before spring break, and that will be like a makeup day, okay? So we are going to finish these sections before that. And you're going to find, I think, tangent to be really, really simple. There's going to be so many similarities between sine and cosine and tangent, okay? So that's why I wanted to do that quiz. Really try and make sure you understand sine and cosine, got that solid, and now we're going to work on tangent. So many similarities, okay? First thing is, and I'm going to jump right into it because there's way too much stuff here. Basically what's saying up here is that tan is sine over cosine, y over x, okay? We memorized a whole bunch on the unit circle. We've also had to find tangent just with triangles, right? Opposite over adjacent. There's so many different ways you can describe a lot of these relationships in right triangles, okay? And the same exact way I introduce sine and cosine to you, I'm going to introduce tangent, which is, let's talk about the 5 key points, the starting points, the parent function points, and then I'll show you what we do to those points. We stretch them, we shrink them, we shift them left and right, we stretch them left and right, okay? But instead of using all of that, don't like it, here's what we're going to use. Make our own chart. Let's use this space here. And we're going to pick 5 points. So let's just make space for 5 points. 1, 2, 3, 4, 5. Okay? And then we'll graph them at the top of the next page. You'll see we're going to graph them. But I'm going to tell you what the 5 thetas are that we use and explain why as we graph them. So you know how in sine and cosine we use like 0 to pi. We use little different ones on tan. We start with negative pi over 4. Start with a negative angle, okay? And then we go negative pi over 2, 0, pi over 2. I'm sorry, pi over, I did that backwards. That's a 2, so sorry. That's a 2 and that's a 4. I apologize. Okay, so pi over 2 is on the outside. And then pi over 4, and then 0. So let's talk about what the tan values are at these thetas. Let's start with 0, okay? So let's look at the unit circle. So as I said, tan is y over x, or sine over cosine, so that's 0 over 1. At 0, the tan is 0 over 1. 0 on top is just 0, right? 0 over 1 equals 0. So tan at 0 is 0. Let's go up to pi over 4. That would be y over x. This is one of the ones we memorized, right? Square root of 2 over 2 over square root of 2 over 2 equals 1. And then up at pi over 2, same thing, 1 over 0. That puts a 0 in our denominator. So tan at pi over 2 is undefined. We actually write undefined. Now let's go backwards on the unit circle. So remember, negative angles wrap this way. On an XY graph, it's just going to the left of 0, but picture it on the circle, we're going this way. So, so here would be negative pi over 4, right? Coterminal, use the language, negative pi over 4 is coterminal with 7 pi over 4. That'd be negative this value over positive this value, which would equal negative 1. And same thing on the bottom, negative pi over 2 is coterminal with 3 pi over 2, so it's negative 1 over 0 again, which would be undefined. So the reason we pick these 5 points is because they're the easiest to graph. Remember we always, like when I did these XY charts with you with sine and cosine, then we pick out the 5 easiest ones. I just went right to them right here, okay? So these are the ones we use as starting points. Let's graph them on the next page. Anywhere you see the word undefined, that is a vertical asymptote. I always start with graphing my asymptotes. So I'm going to start with negative pi over 2 with a, with a dotted vertical line. So I have an asymptote at negative pi over 2 and pi over 2. Always, so let's remember that we're never going to make an XY chart again, right? We started out like that with sine, cosine, and now tangent, just to see where we start. Then we never do that again. We just learn the behavior of the graph, and then we move it around the coordinate plane according to those A, B, C, D numbers, which are going to be the same numbers we use in tan, okay? So sine was like middle, up, middle, down, middle, and cosine was up, middle, down, middle, up. Tangent has your asymptotes on the outside, an x-intercept dead center. Wherever those two asymptotes are, we have an x-intercept right in the middle. Then halfway between the 0 and each asymptote, you will have your other points, right? Pi over 2 up at 1, and at negative pi, I'm sorry, pi over 4. And at negative pi over 4, keep messing that up, we're down at negative 1. Now look at your x-axis. Get used to like understanding. If this is 0 and that's pi over 2, half of pi over 2 would be pi over 4. It doesn't have to say it there. We know that between 0 and the top of the unit circle is pi over 4. And then it looks like a line, right? It looks like you can connect it with a line. You obviously can't because you have asymptotes. I call it a squiggle. It goes like this, arrows on the end. So the range is from negative infinity to infinity. It goes up and down forever, but it's contained by those asymptotes. And that's what almost every single graph, I mean, that's the behavior of every single graph. 2 asymptotes, an x-intercept in the middle, and then halfway in between, you're going to have your up and your down, and then you squiggle. Okay? We have a point of inflection. Remember, point of inflection is where we change concavity. So see, we're concave down from negative infinity to 0, and we're concave up from 0 to infinity. And so a point of inflection is where that changes. And that's right there in the middle at 0, 0, a POI. Okay? So I just keep having these terms come up again and again. The more we are exposed to them, the more we're going to learn them. Okay? Let me kind of skip through a lot of that and show you what the basic form looks like. Now, we're only going to introduce A and B today. I'm only going to introduce those two letters. They're in the same exact place as they were for sine and cosine. Tomorrow, we'll put a C in there. We'll put a D in there at the end. C and D, shift it left and right or up and down. Same exact thing. But today, we're just going to work with A and B. One more thing I forgot to talk about up there at the top. What is the period of this parent function of tan? Now remember, the period is how much of the x-axis our graph takes up. That's right. Did you hear that? Say it louder. Pi. It's pi. It's 1 pi. What was the period of sine and cosine? 2 pi. Right away, separate them. Sine and cosine, period is 2 pi. Tan, and later his friend cotan, period, is pi. Okay? That's how much of the x-axis we use. It's really important that you guys can look at the graph and tell that. We're going to have a mathematical way of doing it, same way we did before, divide your period by b, same exact thing. But sometimes it's just so much faster to be able to read the graph. And remember, when we're talking about period, it's always going to be positive. It's distance, basically. Okay? So from negative pi to 0, negative pi over 2 to 0, that's pi over 2, right? That's half of pi. And then another half of pi. Half of pi plus half of pi together makes 1 pi. Okay? So let's see what happens when A is negative. So if I were going to start pulling out information, A and B of this, A is negative 1. Ooh, does somebody want to correct me? I've been telling you forever amplitude can't be negative, and that still is true. But in tangent, we don't call that amplitude. It's A. It stretches your graph up or down vertically, flips your graph. It's similar to back when we did parabolas, for example. This is a quadratic. A stretched or shrunk your graph vertically. It flipped it over the x-axis. Same thing. A does the same thing in every graph. It's just with sine and cosine, A also got the fancy title of amplitude. So A can be negative. But if you want to write it so you don't mess it up later, because I'm sure I will accidentally call it amplitude, you will too. So if you pick how you want to write it. But in these situations, I would not mark you wrong for calling A negative. Okay? And B would just be 1. So let's just remember, how do you find the period? Because B doesn't go on the graph, right? B does not go on the graph. So anytime you want to find your period, you take your parent function 1 and divide it by B. Okay, so the same thing we did in the past. We would do 2 pi divided by B to tell us how long our thing was. But so we already know that if B is 1, our asymptotes now are just at negative pi over 2 and pi over 2. Start with your asymptotes. We don't need an XY chart. We know the behavior. There's an x-intercept dead center. But here's where it changes from the parent function up above. If there's a flip, just like I used to say with sine and cosine, any of your ups become downs and any of your downs become up when you have a negative. It just flips those points. Same thing. It's going to flip this one down and this one up. So what it kind of looks like, and it can help you remember, it looks like the end behavior of a line with a negative slope, right? If you had a negative line, it would have a negative slope. Same thing here. So A being negative simply makes you squiggle in a different direction. Okay? Now, let me introduce B to you. When there's a B value that's not 1, it's going to change how wide or narrow horizontally we are. Okay? So just real quick, I'm not going to go through all of this, but this is just kind of breaking down what the 5 points are, which we already did. You've got your two asymptotes, an x-intercept in the middle, and then you split this difference to get your up or your down. Okay, so it just kind of remember that behavior. You can graph tangent anywhere. The hardest part is going to be the x-axis. We have to change the asymptote sometimes, and that's where a little bit of algebra comes in. How do I, make that happen? So let me show you what I mean. All the way down here. So I'm going to just use this space to tell you a little thing about asymptotes. Anytime, that should have been in parentheses. Anytime your B value is not 1, your asymptotes are going to change. So you have a B value here. So let's just break it down. A would be -1, right? B would be 1/2, right? A number next to x, 1/2 x. This one would be A is 1, B is pi over 4, okay? So since B isn't 1, I'm going to have to change my asymptotes. If B is 1, my asymptotes are -pi/2 to pi/2. So here's a new word for you. Let's use this space up here. A word called argument. Don't ask me where it came from. But whatever's in your parentheses is called your argument, okay? And how we change our asymptotes is really pretty simple. We set our argument in between our two parent function asymptotes. So let me show you what I mean. I'm going to actually use this space down here. I don't have a lot of space. Okay, so my argument is x over 2. That's my argument. So what I'm going to do, and I'm going to use this space here, is I'm going to set my argument, which is x over 2, in between my two parent function asymptotes, and then I solve for x. Think about it. If b was 1, it'd just be 1x in between those. There'd be nothing to do. But here we have x divided by 2, so I'm going to multiply everybody by 2. Think about how you would do it if there was only the normal looking inequality. To get x by itself, you would multiply both sides by 2, right? This would cancel, this would cancel. You'd be left with pi on this side. Of course, I can't fit it. X would be right in the middle. But don't forget to do this side too. Multiply by 2, those cancel, and I'm at negative pi. So I have new asymptotes. My new asymptotes now are at negative pi to pi. And I'll show you that again. Okay, so there's my asymptotes. Now I can graph it, right? I have an x-intercept, dead center, easy to tell where it is, right? Otherwise, I would have to do midpoint. I don't need to see all that work. It's visual most of the time. It's really easy to see. We have a flip, so I want my points to look like a negative slope. So I'm going to rise on the left up to 1 and fall on the right, so that my squiggle has the same end behavior as a negative slope. Now, we're going to put graphs left and right. So this is really important. We have to know how to fill the graph if they want us to. So a lot of times they'll just say 1 period or 2 periods, but in this case, we're going to go ahead and fit in there. So if you know the period, what is the period? Let's fill that in. 2 pi, right? So from here to here is 1 pi, here to here is 1 pi, total of 2 pi. So if I'm going to make another period, I have to go out 2 pi from this asymptote, right? I need a whole 2 pi space to the right of it. So if I add 2 pi to pi, it's off the graph. That doesn't mean you can't graph it. So let's go back to how would I make my x-intercept. My x-intercept will be exactly a period away. So I'm at 0. If I add 2 pi to it, I would have an x-intercept here. Go this way, I'd be at negative 2 pi, right? There's where my x-intercepts will be. Now, fill in the rest. This is my model. These two follow this guide. So I'm able to fit a point to the right. I can't keep going because the graph isn't there. So I only have a piece of a squiggle. On this side, I can only fit a point to the right. So I'm copying this piece of my graph. You can picture that if my XY coordinate plane continued, it would be off here, but we don't write it. In fact, that would be wrong. You have to be able to make parts of squiggles, okay? Now, let's do this one real quick. I got my A, I got my B. I'm going to need asymptotes. because there's a b value, I have an argument, let's say it like that, I'm going to have to do something. So I'm going to go up here, sorry. So I'm going to take my argument, which is pi over 4x, and set it in between pi over 2 and negative pi over 2, and then get x by itself. Now, let's just simplify it. I'll cover the left-hand side just to make it look a little simpler, and use this as my, what am I going to do? So pi over 4 times x. Technically, I'm dividing everybody by pi over 4. But since I have fractions over there, and this is a fraction, why not do the other way of doing it? Instead of dividing by pi over 4, I can multiply by what? 4 over pi. So then whatever I do to the middle, I have to do to the both of the asymptotes. So you should be left with x in the middle. That's your goal. And then I have the pi's will cancel, right? Pi's cancel. And I have 4 over 2, or 2. Pi's cancel here. Don't forget about that negative. That's negative 4 over 2, which is negative 2. So these are my asymptotes for this graph. So that's the algebra I was talking about, being able to single out that x. Okay, look how nicely my x-axis is set up for me. Notice there's no pi's in there. That's okay. Sometimes the pi gets eliminated. So I like to start with my asymptotes, dead center. Am I flipping? No. How high am I going? 1. So it kind of just makes a line, right? It looks like a line. What's the period? 4. Just 4. Now, if you couldn't tell by looking at it, you can always use your math. B is period is pi over B. And if you flip that, you will get 4. But I don't need to see that. Most of the time, you can just look at the graph and come up with a period. Now, real quick, almost done. Going to the right and left, let's fill the graph. If I'm a period of 4, I would have to add 4 to 2 to the right. That would get me to 6. Guess what? This is 6 right here. That is 6. I can fit, and then at negative 6. I can fit 2 whole squiggles more on this graph. No halvesies. Dead center. And then just, this is your model. Follow this guy. Squiggle. And squiggle. Have any of you ever been to Romania? You have? My son is moving there. I gotta ask you questions. Yes. Okay, no. I have a picture of it. I have a picture. I don't know. I have to thank him. I have it in my phone. Well, I know he's flying into Bucharest, but he's not going to. Where his city is 5 hours from my house. He just told me this 2 days ago. I'm still reeling from the fact that my son is moving to Romania for 6 months. To be near Egypt, where he has a Christian missionary, he's a Christian missionary, and he is going to go spread the word of the Lord, where they kill Christians. So, yeah, he's going to my son looks like the most typical American dude, okay? Like, this is my son. He's 6'4", he's just muscle bound, okay? No, he's not going to, because he's like, I can't look American when I go to Egypt. He has a cross the size of half of his chest on his chest. That's a tattoo. He's like, I gotta cover this up. I'm like, oh my gosh, don't bring any white shirts. Like, it's crazy what he's doing. He's very, very motivated by his faith. So let's just leave it at that. Okay, I'm gonna talk to you more. All right, C22, 1 through 9. I'm gonna do number 2 and number 5 with you. This is page 92 maybe? Page 92. Okay. I'm going to do like number 2 and number 5 with you. I thought 1 was a little bit easier, so I want to do a harder one. So just stay with me if you want, or if you're super confident, you can go on. So we're going to graph 2 periods of each of these. Everybody get it? 322. We don't have a lot of time to work. All right, let's pull information off of this and then graph it. So A would be 2 or negative 2, however you want to write it, right? Or 2 with a flip. All right, then the period is pi divided by B, right? Here's our A, there's our B. And there's no simplifying here. So pi over 2. Asymptotes are next. Let's use this space here. So take your argument, and the argument again is whatever's in parentheses. That's 2x. And set it in between pi over 2 and negative pi over 2. So you have to memorize the pi over 2, negative pi over 2. We've got to know that that's our starting asymptotes. Now, think about it. To get x by itself, you divide by 2. But look at what you're going to have to divide by 2. Fractions. So in this case, instead of dividing by 2, again, I'll multiply by the reciprocal. Do it now. So instead of dividing everything by 2 and then like, oh, keep, change, flip. Instead, let's multiply by 1/2 and save ourselves a step. I get negative pi over 4. X should always be by itself in the middle, and pi over 4. So our graph is between these two. So our asymptotes are at negative pi over 4 and pi over 4. So let's put our asymptotes on there. So in between pi over 2 and 0 would be pi over 4. So notice how skinny, right? How narrow horizontally our period is. That's because we have a 2 here inside. Remember, this would be a horizontal dilation by flip it 1/2. It really is tiny, teeny, tiny. So x-intercept dead center hits a flip, so I should look like this. So in between those at 2, in between these two at negative 2, right? And then your squiggle. Now, we have to do another one. You can go to the right or the left. It doesn't matter. This continues on forever. The directions are just give us 2 periods. So we use this information to get our first one. Now we have to get a second one. So I'm at pi over 4. I'm going to go to the right. I just think dealing with positive numbers are usually the easier way to do it. So pi over 4, I have to go out half of pi. So I'm at pi over 4, and I have to find where half pi is. Okay? So without having to add with common denominators, use something you know. It's a quarter plus a half. That's 3 pi over 4. Right? A quarter plus 2 quarters is 3 quarters. So, but you can also, a lot of times, these graphs are drawn for us. They're really, really nicely done for us. So you can kind of eyeball, right? It takes up 1, 2, 3, 1, 2, 3. So you might be able to just find your next period by looking at the graph. But I'm just trying to show you both ways. And then the rest of it's just, I've got this model to look at. There's my x-intercept, up 2, up 2, down 2, like this. Okay, that's it. All right, let's do number 5. I'm still doing homework with you. Be okay with going out of order. It's okay. It's okay, it's okay. All right, looking at a graph, can we pull all the information off and write the equation? Okay, so the first thing I like to do is when I take a look at the graph, I want to find those asymptotes. They tell me a lot. So you can see that your graph is approaching negative pi, and it becomes really clear once you identify what they are. You can really see, okay, that's dead center between these two. It makes sense. So that, from negative pi to pi, then my next one would be 3 pi. So I actually have 3 asymptotes on my graph, right? I have negative pi, pi, 3 pi. I'm just kind of listing them like this, no special notation. Okay, what's the A value? So if this is my x-intercept, halfway in between, I can't really see it. I just put my glasses in. I think we're right here, right? We're at pi over, negative pi over 2. That would be halfway, and then negative pi over 2. So what is my A? Well, it's 1, right? That's how high and how low I go. And it's a flip. So you can call it a negative 1 if you want to. How long is the period? From negative pi to pi. How long is that? It's 2 pi. We use a total of 2 pi. You can look at it from here. From 1 pi to 3 pi is another 2 pi. That distance is 3 pi. 2 pi, sorry. Now we need to write the equation. Remember, to write an equation, you need A, B, C, D. Well, we'll take away C and D today. We'll add C and D tomorrow. But we need A and B. All right, A is always easy. Remember, B is not the period. They're not the same thing. But we can get B from that formula. Same one we used in sine and cosine. The only difference is instead of dividing 2 pi divided by the period, we do pi divided by the period. And we get 1/2. So B is 1/2. We're ready to write our equation. Y equals -1. You don't need to write the 1. Tan, our argument, for view 1/2 x. Notice the smaller your b, the wider you are, because when you take it out, it's a horizontal dilation by 2. Remember, we had to learn to flip that, and it makes sense. It's really much wider. Okay, so that's the homework. I'll come around for questions. Anything, Tyler? No. Yeah, no. I'm going to give it to you. I didn't know if you finished copying. You did or didn't? I did. Okay. I just can't fit 8 and 9 yet. Very well. Yeah. Mm-hmm. Right. So I So minus and negative become positive, 2 pi over 6 or pi over 2. So this one was a little bit trickier, guys, to find the period. But I'm showing you up here. And Levi, you could have used any of this, and you would get the same thing. The period's the same as you go through. Yeah, 6 and 7 are going to be a little challenging to find the period, maybe. think about how you can do it. I did show the work on number 6.
Those are actually phase shifts.
That was